Welcome to my talk, MegaCode to Facility Gates. And in this talk, I will simply present what I did with this remote. It will be about electronics, about microcontrollers, about software-defined radio, but I won't go into details also because there are not a lot of details. It's at a simple level, so everyone should be able to understand it. And even if you didn't do any hardware hacking yet, this talk should emphasize you to do it because it doesn't have to be hard. Also, it's not a new attack. I will spoil it from beginning on. The remote is handling a fixed code, and I just replay this code. So no new attack on there. But the way to achieve it, this was quite fun. So if you ever wanted to make some electronics and you find that LEDs are boring, but you don't know what to do, or if you wanted to play with software-defined radio, but you think that software-defined radio or radio transmission are complicated, which they are, then this is a perfect talk for you. Yeah, there's one who is happy. That's good. One happy people. So I looked at this remote. I was in the US for a couple of months, and they gave me this remote to access my building. They gave it to everyone. And I wanted to know how secure is this access gate, the access gate to the building. So this remote is used for the garage. In the US, you're almost forced to have a car because public transport is not that good. So they give it to access the garage. But also, they give it to access the main entry. Nobody uses it, but it's still there. And what's important, they give you to access the pool area. Don't ask me why it's fenced. I also find it a bit stupid, but it's fenced. You have the remote, you can access it. And we will see that the hot tub will play a very important part in the reason why I looked at it, simply because there is this gate. You can jump over it, but it's a lot more fun to hack it, isn't it? So, they provide you one remote which is only for one part of the building. You shouldn't have access to the other buildings. And as you can see, this facility complex has a lot of buildings. And this remote is not only used in this complex, it's used in a lot of complexes in California, or at least just by driving by, I could recognize some of the things. And if you have seen this remote, then it's exactly the same system. But before starting to already disassemble the remote, it's important to find information, particularly if you're a beginner. If you already have done a lot of hardware hacking, then you can already disassemble it, look at it, figure out what component is what it does. If you already did software-defined radio, you will probably find out which kind of modulation it uses in the beginning. But if you've never done it, it's pretty hard. So finding some documents about the remote will help you to indicate, okay, this is how it works, this is how it modulates, and so on. And I can only emphasize that it will save a lot of time. So we need to identify the remote. We can see on the front, there's not a lot of information. On the back, nothing written. There is even a sticker missing. And if you open it, you see that it doesn't have, the electronic is pretty simple. It doesn't have a lot of components, but it doesn't tell you who is the vendor or what the product is. On the back, too, it doesn't tell you. There are even two stickers with, I think it's the code which is transmitted, but they've never really figured out how they encoded it, how they transmitted it. It's not too important, though. But we didn't find any information. Whenever there is a transmitter, there is a receiver. So you just run around the building and try to find the receivers to know if they have markings. On the garage gate, the receiver is on the top. It's just a black box. It doesn't tell you a lot. On the pool, it's also just aluminum box, no markings on it. We still don't know. At the main entry, this is where you find a fancy dial pad to contact the resident. And we see on the top, it says it's from Linear. So at least we know the vendor, probably. And after such hard work and running around the building, you enjoy the hot tub. And this is where you use the second skill, your social skills, simply because every resident has a remote. So you make the acquaintance, you make new friends, and you ask, please, can I have a look at your remote? And this one had the sticker. And it's particularly useful. So from the sticker, we find the vendor is Linear, and the product is ACT34B. On the website, we can find it, so the product still exists. We know it operates on 318 megahertz, it can send 1 million codes, but the manual doesn't tell a lot. And we already know which frequency it transmits, but we want to continue and find more information. Again, if we look at the remote, on the top, you will see there is an FCC ID. And this is one thing I know of in the US, is that whenever a manufacturer wants to produce something which transmits radio, they have to comply to some regulations. And they send test reports to the regulation authority, FCC, to show, okay, I transmitted that power and it complies to FCC Part 15 for radio transmission. And the FCC shows you these documents. And compared to the manual, these are technical documents. So this is where we find the really neat information. And we can see that they provide a lot of data, although they don't have to provide so many. So first, the test report to tell you what kind of transmission it uses. And here we see it's amplitude modulation, something which is very simple. So the signal, if it's strong or not, gives you the level. It's also pulse position A1D. And if you look in Wikipedia, A1D stands for amplitude. 1 is just one channel, 318 megahertz. D for digital, I think. So there's only 2 levels, either on or off. Very simple transmission. And the data is probably coded in pulse position. I even provide you some information about how the MegaCode code is sent. You have 24 bit frames, 24 bit frames. Each bit frame is 6 milliseconds long between each other. And within each bit frame, you have a 1 millisecond pulse. So you have the remote goes on and just transmit very loud at this frequency. And they were so kind to provide with a timing diagram. And everything just because of we found everything to the FCC ID, and we almost already know how it's encoded. So we spared a lot of time. And as we can see, we have a sync bit, so the receiver knows, okay, there's a signal. We record the 20-bit system code bits, the 3 data bits, and then there's a blank cell before you send the next code. And as they're written, each bit frame is 6 milliseconds long, each pulse is 1 millisecond long. Now we know how it transmits, it starts to play with software-defined radio. And even for entry level, you have this cheap RTL SDR, which everyone speaks about, only $20. It's nice software-defined radio. You look at the frequency. Here I use SD rangelove. You tune to the frequency, and this is on the left the frequency. On the top, you can see a fast Fourier transformation, which will tell you at which frequency there is a strong signal. And we see there's a peak at 318 megahertz. On the bottom, you see a waterfall diagram. It's almost the same that on the top, but you have the timing component. So you can see over time how the signal is, and you can clearly see the pulses every time, on and off. Whenever there's a yellow peak, it's a pulse. It seems to correspond to the specification, and that's good. Software-defined radio can be complicated, and GNU radio is complicated, and I'm not a fan of it. Oh, I don't know how to use it. It's probably very good, but we want to keep things very easy. And we know it's AM modulation, so I just use a tool called RTL FM, which can do AM modulation. It's thought for listening to audio using the software-defined radio. So you tune to the frequency, you tell it AM frequency, it's AM modulation, you put it in a file, and then you open the file using any audio editing tool. And here we can see again 2 times 24 pulses. If we look at the details, we find the pulses are 1 millisecond long, and you have groups, you have bursts, and you have bit frames of 6 milliseconds. And we know the information is pulse position. This is quite useful because it's a bit frame, so there's only 1 bit per frame, and then there's a position. And if you look at it, if the burst is in the first half, it's a 0. If it's the second half, it's a 1. This is not written in the documentation, but you figure it out pretty easily. And we know how it's encoded. So we wrote a program which just takes this demodulated data and finds out the code. It's pretty short, 107 lines of code. It detects the edges, it groups the edges into pulses of 1 millisecond, then it knows, it groups the 1 millisecond pulses in group of 24, and then it decodes it. And here we can see on the left the value which are decoded, the 24 bits, these 3 bytes. And we immediately see it's exactly the same code all the time. It's individual per remote, but it's actually the same. So we have a replay attack. If we can record it, and if we can send it, we have a clone of the remote. Only using this documentation which we have. So we want to send it. Look again at the FCC ID. Can we reflash the remote using our own code? In electronics, you have a board layout which tells you which component is where. This was also provided. You can see footprints for putting a switch, S1, and every component has a reference. S1 is for switch, U1 is for the microcontroller, and so on. Basics of, so you will learn how to read printed circuit boards. There are also schematics. Schematics are a bit more abstract way. Before you do your circuit board, you want to just to know which component is connected to which other. Where they are placed and how they are connected, you don't really care. You just want to find out how they're connected. This is what schematics are for. And if you learn a bit how they work, you will find out there are the switches on the left, the microcontroller in the middle, the clock just behind it for the 318 megahertz, and then the antenna. This is also what we see on the identifier again on the board, because we have the reference, which tells us U1 is the microcontroller. Look for U1 on the board, you will find the microcontroller, and you will find the clock, the switch, the antenna, and some passive components. And even if you didn't do any electronics, you already pretty much know how to read schematics, how to read boards, and how to identify components. The problem with that one is that it uses a microchip PIC12C microcontroller, and this one is only one-time programmable. So you can look at the... I know this because of the schematic. The schematic told me it uses this chip. And if you look for microchip, which is a big microcontroller, very known for hobby projects, you'll find it's only one-time programmable, so I cannot reflash the code on it. It also has code protection, so I cannot read the firmware on it. This way I cannot flash it. That's a bit of a shame. But the simple is so easy that probably somebody already did a compatible device. So you use your Amazon and eBay skills, you look for linear MegaCode compatible remote, and you find one which is not by the same vendor, it's by Transmitter Solutions. It's the Monarch 3018 LIP W1K. It tells you 380 megahertz, perfect, the same frequency. It's compatible with the linear ACT31B, that's what we have, and it's programmable. That's interesting. The other one was not programmable. The manual doesn't tell you how to program it. There's a small section tell contact your manufacturer, but there's the FCC ID on the right, and we've seen the FCC ID is pretty interesting. So you look at the FCC ID, you don't find as much information as the previous one, but at least you have a picture of the interior, and you will almost immediately see that on the top there's some pin header which is unsoldered, and this indicates that it is the programming header which you should connect to program it to. We byte it, the programming header is the same. We can read from the top markings on the chip what kind of microcontroller it is, and this one is flashable. It's again a microchip PIC microcontroller, but it's based on flash and I can program it. The next skill will be soldering. Even if you never did any hardware, you just have to solder the pins on the right side so you can connect your programmer and program the chip. And for entry-level soldering, it's pretty good. It's pretty easy to make. We also want to know how the things are connected. This time they didn't provide the schematic, but we learn a bit how to read boards. We can find the microcontroller, the clock, one LED, one switch, the programming header. And if you check with the multimeter how they are connected, you find the schematic again. And you can write your own schematic this time. Microcontroller, clock, switch, pretty simple board actually, even simpler than any Arduino or things like that. So even if you didn't use Arduino, you can use this as an entry programming. We figured out how everything is connected. We know how the signal is modulated, how you have to send it. So it's time to write our own firmware and just enable the clock and the transmission at 1 millisecond long every 6 milliseconds, and we know the pattern. And if you could switch to the camera here, so yeah, you wrote the program. It's pretty simple, 125 lines of code, and this way I can flash my code on it. Oh. Where is my terminal? Ah, here, there's some. Can you show the camera? Okay, they will. While they do it, I will just start the software-defined radio so we can really see the transmission. Which terminal is it? Software SD rangelove. So here we have the software-defined radio with the remote, with the antenna. The remote is here. Now we enable it, and if I press on it, you see the transmission which is made, and you see it's on. Oh, you don't see it anymore. This is a receiver. I'll talk a bit later. And if you see on the side, whenever the code is transmitted, the LED stays on. So it means this transmitter will react to this code. Normally it should blink blue, so I will do it by hand. It's somehow broken, like always, demo. So it will blink blue. It only works with this remote. It does not work with this remote. As you can see, it doesn't do anything for now. Oh, yeah, that's... So we've identified the frequency. We'll just quit it. And then we just use the decoder which we had. Press on the remote a couple of times. You exit, and here we see the value which we decoded on the left side. We know which value it uses. And if we look at the other remote, which is here, I think I have to enable it. Yeah. Make on operation succeeded. If I transmit this one, so here you can see that it transmits using the LED. I'll find that it uses another code. Now I will simply edit the EEPROM with this code, which is 21.8a. Flash it on it. So you use a standard, I use a PIC-chip 2 programmer. This is generally what you use to flash these microcontrollers. Please flash, please. No PIC-chip 2 found. The USB is here. Connect it directly here. That's not USB, this is USB. Oh, flashing. Flash EEPROM. Make on. So now the thing is open, and if we look here again, and if we send the code, then we see that it showed open the gate. And this is how we clone codes. Back to the presentation if I find it here. I didn't stop at just cloning the remotes. We have one code for one remote. We want to have even more. How about getting codes from other remotes? You can do it with software-defined radio again, but it gets so this demodulator which you have is very centered on frequency, and the bandwidth is not is very narrow. So with using software-defined radio, it's quite complicated to record far away one signal. You have to play with the gain and so on. I'm not good at software-defined radio. I'm a bit better at electronics. So when there's a sender, there's a receiver. Just buy a receiver online, formerly the MegaCode. Look at the receiver, open it. You see again, not a lot of components. And we already learned how to identify them. You have microcontroller, the antenna, the radio filter, the voltage, then some memory, which memory where you can store codes. And generally, this is the memory which is used to read out which code is allowed or not. It's a single layer design, so on the back you will see all the connections to all the other pins. You can read them visually, and using the components which you can identify in the path, you can already figure out who is connected to what. Here we created the schematics again. It uses a PIC which is only one-time programmable. We don't want that, so we on-solder the chip. That's your next skill which you will learn. Not too hard, just vacuum pump or solder wick, and they're pretty resistant, this chip, it's hard to break. You put your own chip, which is the same, but just flashable. The name is the same. You program everything you want. You already know how the modulation works, and you already wrote code for demodulating. You already wrote code for the microcontroller. So you do exactly the same, but just on a microcontroller, on this microcontroller. And then you put it just next to a garage door, and you power it to a USB, and you wait until lots of people go home and go back and record lots of code. So you can impersonate anyone you want, just because you have the code and they are fixed. But another problem is that you know when they leave home and you know when they come back. It's individual code. So you probably could go home and then steal everything and have enough time to leave back. The pool, again, this is the last piece of information. Very important, simply because the pool is fenced, and at 10 o'clock they kick you out. So they have a security guard which comes in at 10 o'clock, triggers his remote. I wait with my decoder, I record the security code, and I have the security code and enjoy the hot water. And with the security code, I can access the pool after 10 o'clock. I can access every building, and you could access the security room with all the TV. And if you don't want to wait for security, you take one working code, you flip the bit, you flash it, you test if the gate still opens, and this way you find which bit is important, which bit isn't, which bit is irrelevant. And from the 24 bits, you have only 15 bits which are relevant. So you could write a firmware on this remote which just starts brute forcing the code. And you don't have to find one code, you have thousands of residents. So with 15 bits of thousands of residents, it's pretty easy to find the right code to enter the same building. But because we're not evil hackers, we tell the vendor, and as always, the vendor just doesn't care, even if they provide security products. And I also show this talk because solutions to it are quite easy. These are called rolling codes, where the codes change all the time, but you have a fixed seed. If you do such a system, you should use rolling code. So it's their fault if they don't do it. What we've learned is that it's not hard to do hardware hacking. We reverse engineer a real device used for security for gates. We improved how we search for documents, FCC. We make new friends at HotTub. We know how to program an EC microcontroller. There are lots of code examples which will help you to program this one. It's really very well documented. We use software-defined radio. At this level, it's not voodoo, it works. We know how to solder and desolder. We had fun. And if you want more info, there's a wiki, there are 2 videos which go more into details, and the source code is also available. And with that, I'm open for questions.
Thank you very much for this great talk. So, any questions? Please line up behind the microphones. Oh yeah, number 4, please.
Hello. I work at a research facility. It's an accelerator facility, and I've got access to my laboratory rooms with this stuff. And there are really expensive equipment behind the doors. So the first thing I'm going to find out is if this works. If it doesn't, you mentioned this rolling codes. Mm-hmm. So if it doesn't work like that, what is rolling code, and is it easy to break, or is it impossible?
There are solutions for not cloning remotes, and this is partly important, for example, if you have a car. Because you don't want everyone to steal the car, and you have cars on remote, the car industry also use a lot of time rolling codes. And how it works is that you have one seed in the in the remote, and every time you press on the button, it generates it calculates a hash, some kind of a hash of this seed, and every time it changes because the counter increments. And in the car, it has exactly the same seed. It knows this remote has this seed, so I know which code will be next. And the code every time will be completely random. So you don't know for where it come from, you don't know the seed. And if you have a central building, then you have a central remote system which knows which code is transmitted. So they should use rolling codes if they have central system. If they don't have central system, it's a bit harder because you need to synchronize the two. But yeah, try to find one with rolling codes. And you can, using software-defined radio, you can see easily if it uses rolling code or not.
Okay, thank you.
The internet has a question.
Okay, yeah. The internet wants to know, or somebody on the internet wants to know why you didn't get into, or if you did get into any kind of trouble because of you breaking into the hot tub or
well,
being able to open any of them doors.
I haven't been to the security room because I'm not interested in the security room. I'm interested in relaxing. And also, in this building, it's not really important to have a remote and to have all this hassle of reverse engineering because you see the hot tub barrier is pretty low, so you jump over it. And around the building, you will always find a door which is open. So you can always come in the building. And I had no problem even with the security. I mean, they don't see if it's a cloned remote or not.
One more question from the internet, please.
Yeah, somebody wants to know about if it's possible to open cars with this.
No, not new cars. New cars use rolling codes, and they have stronger encryption. So if your car uses this, you should sue them. But generally, cars have rolling codes, and you can not use this technique. So it's a lot more advanced in cars. Try to use something which is less attacked.
Okay, thank you.
So I guess we have time for one more question from the internet, once more.
Okay. I was going to say that there's none, but there is one now. And that is, what other stuff can I open with your method?
Well, we've did it for one garage remote, and generally garage remotes are not very secure. Try to find another one. This is just one product from one company, which is in California. In Europe, they probably will use something completely differently. So look at your garage door or the garage door of your neighbor, things like that.
Okay.
Oh, very, very simple devices. When they are cheap, generally they are simple. So look at that.
Okay, thank you.
Thank you very much.
Thank you.